Alright, so now let's do a little bit of programming. Again, if you are already familiar with programming, you can skip this part and move on to the next section. We are going to do a little bit of bash scripting, some Python scripting, and a tad bit of C. You don't necessarily have to know any programming to do this class. The only time we're going to see any programming that you have to do is in the exploit development section, and I make it pretty easy for you. I'll give you exploit skeletons, and you just have to fill in the exploit string. So don't worry if you're not a programming expert, but I would encourage you to pick up some programming if you haven't already, if you want to continue in pen testing, or anything in security really. Alright, so now let's look a little bit at programming. Like our Linux basics, this might be one that you could skip if you're already familiar with programming and scripting. You aren't going to need programming and scripting for this class in particular. The only time it really would come up is during the exploit development section, which I give you exploit skeletons specifically so you don't have to focus on the scripts and the syntax of the particular languages we use. But if you are going to continue with exploit development, you're certainly going to have to know at least some scripting, and probably just with pen testing in general. Certainly if you ever want to write your own pen testing tools or plugins for some of the existing tools, or say a Metasploit module, and you may just find some script just doesn't work, and it should, and you're on a time crunch, and you need to be able to fix it. So it's certainly worth knowing programming. I mean, certainly there are plenty of pen testers who aren't programmers, but at least having a small amount of programming knowledge, I would say, would be pretty essential. So we're going to start with bash scripting, so B-A-S-H. Again, there are slides for this, as with all the modules, for you to look at accompanying the videos and as you work through this. So I've just come up with a few little exercises here. So for the bash script, we're going to basically do a ping sweep. So we saw ping in the previous section. We looked at, once we had set up our network, pinging another system to see if it was alive. We noted that the system doesn't necessarily have to respond to ping in order to be alive, but it's a good indication. So for instance, we could ping www.google.com, and it replies, so we get 64 bytes from the IP address of Google, so we are getting a reply. If we do ping w.google.com. Hopefully there's no, there is. Maybe that's, so how about w.bulbsecurity.com? Something that doesn't exist. So now we're not getting a response. So there is no w.bulbsecurity.com. So what might we want to do to make this a bit easier for us? If we, say, had an entire Class C network, so our /24 or 255.255.255.0, so we had 254 possible hosts, and we wanted to see which ones were alive, which ones were at least answering to ping. We could do it manually, but that wouldn't be much fun, would it? Our time is much better spent on things that computers can't do easily. So we might want to write a script. So let's create a little bash script for that. I'll make this a little bit bigger. And so I'm going to use Nano. Again, I like Nano. You're welcome to use VI or another editor that's on here if you're more comfortable with something else. I'm just going to call this ping.sh for shell script. And what we want to do first, since this is going to be a script, we want to tell the interpreter, tell Linux what interpreter to use for this. So we want #bang, so hash and then exclamation point, and / for root, bin, bash. So we want to use the bash interpreter since this is going to be a bash script. After this we'll do Python, so we'll use a different interpreter. But for this one, bin bash. And basically in here we can just talk as though we're talking to the Linux system. We're just sending it a list of commands to do one after the other. So we want to say echo. We remember echo, right? That's going to write out to the screen. So I'm going to start with some usage about how to use this script. Alright, usage colon dot slash. That's going to say run this program from the current directory. So we're going to do dot slash ping scripts, or ping script rather, dot sh. And we're going to have it take an argument of the network. So we're going to give it like 192.168.1, and it will ping .1 all the way to 254. So let's make another one an example. So echo example. Well, let's make that a big E so they match. Dot slash ping scripts dot sh 192.168.1. Let's go ahead and save this. I mean, right now all it's going to do is write two things out of the screen. Not particularly interesting, but we will make it more interesting as we go on. So we can go ahead and save this. Again, in Nano, that is Control X and then Y for yes to save changes. So if we just try and run this, we just do ping.sh, command not found. Well, for one thing, that's not how we call it. We need to call it from this directory, because that's where it is, right? We saved it here. So we can't just call it like that, whereas we can do like cd. Well, that just did nothing, or ls, so lots of stuff there. And I'll just clear that out. But if we see our path, so if I echo $path, we can see all of the places that Kali will automatically look for things. So user local sbin, user local bin, user sbin, user bin, sbin, bin. So if our script was in any of these places, it would automatically find it. So if I did ping script.sh, it would find it there automatically. But since we are actually in /root, it's not in our path, so we are going to have to call it by telling it where it is. So remember, dot is our current location, so dot slash ping script.sh. It says no such file or directory. Again. Oh, it's called ping.sh. Whoops. And then it says permission denied. What have I done wrong? If we do ls-l ping.sh. Remember our chmod and our file permissions. We don't have the correct permissions here. We need to execute. If I do a chmod 700, as long as you give root executable permission, you're good. Ping.sh. Now if we run it, we get our usage in our example, which are of course wrong because I called it ping script instead of ping.sh. But we can fix that. Pretty easy. Alright, so we have made it executable. First step down. Awesome. Alright, so what next? We only want to output this if they use it incorrectly. For instance, if we do a netcat and then do, or no, it's not, if I just do a grep and then nothing. We saw that when I did it wrong in a previous module. It gives us help information, so that's pretty typical. So we could do something like that here. What we're going to do is use a conditional. We're going to use an if statement. If statements are around in lots of different languages. The syntax may vary, but chances are you're going to have an if statement. So I'm going to say if, and how we do this in Bash, and again it is going to vary, so don't feel bad if you have to look this sort of stuff up if you know a lot of different languages. So I'm going to say if brackets $1. I'm going to put quotations around $1. So $1 is going to be the first command line argument that is provided. So if $1 equal, so one equal is going to set something equal to something else. So if I just did equal, and then null here. That would actually set it to null. It would basically take what was there and overwrite it with nothing. So that's a very common programming mistake, one that people make a lot when they're starting out, and even still afterwards. As you continue with programming, it may come up. But you need double equals. That's going to be test for equality. So if our first command line argument is blank, then what we want to do, sure enough, the correct syntax is then, which again, that may be different. You may have brackets or something depending on your programming language. So then we want to do these echoes. And to finish an if statement, you say if backwards. Again, that may vary from language to language. So basically all we're doing here is if command line argument is equal to null or nothing, then echo this out. Otherwise, it won't do anything at this point. Of course, we'll want to add in some of that functionality later. Of course, we'll want to make it ping. We'll do that next. Go ahead and save it. Run ping.sh with no command line argument. We get our output. Blah there. It currently does nothing. Alright. So, now we want to add something for if they do use it correctly. So we have our help information. Alright, so if no command line argument, then do this. But what if they do have a command line argument? Then we can use an else statement. If, then this, else. So above the backwards if, we want an else. Now we're going to use something called a for loop. There are different kinds of loops. There's like a while loop. But while and for are generally the ones you're going to see the most of. But what we want to do is say for x in, and then we want the backwards quote, single quote sequence seq 1 to 254 backwards single quote colon do. So again, this is going to be programming language specific. I mean, the key idea here is that we want to do something over and over again a certain amount of times based on certain value. So basically for x in sequence 1 to 254. So x is going to be 1 the first time, 2 the next time, 3 the next time, so on and so forth, all the way up to 254. After 254, it'll finish and the for loop will be over. So for x in sequence 1 to 254 do. So I want to ping, and I want to ping my network combined. So again, my first command line argument is going to be my network. A dot will concatenate. Actually, that's not true. They'll just concatenate by themselves. So like that would be it. But we need the dot between it. We would need 192.168.1 dot, and then whatever comes next. And then we want x, so whatever x is. So the first time, so if we give it 192.168.1 as our command line argument, the first time through we'll get 192.168.1.1. The next time 192.168.1.2, so on and so forth, all the way up to 254. So each time x will be one more. And then to finish, do done. So that denotes the end of the for loop. Again, we have the end of the if at the bottom. We can go ahead and save that. You may have noticed something that's wrong. So if I give it command line argument 192.168.1 in my case. So instead of doing a ping sweep here, we're actually just pinging 192.168.1.1 over and over and over again. So that varies from operating system to operating system. On Windows, by default, it only pings 4 times. In Linux, it's just going to ping forever unless we tell it otherwise. So this isn't very useful. So can we perhaps fix this? Of course, we're going to be here forever. Do Control Z to get rid of it. So can we fix this? My first place that I would generally go to is the man page. And I want to see if there's some way I can tell it I just want to ping once. And sure enough, there is. This -C for count. Stop after sending count echo request packets. So that will allow us to not ping forever. So streamline this a bit. So we want to do ping-C 1. So that should fix our problem. So we got yes from 1, looks like no from 2, no from 3, no from 4, so on and so forth. It will go through and try everything up to 254. I do have other VMs running as well as my printers around here somewhere and whatnot since I'm on the bridge network. So everything that's on the network will call back to me if it does respond to ping, which again it may not and still be up. I'll do my Control Z to get rid of it. So the output is not that attractive, right? The output is in fact pretty terrible. So what did we learn in our previous section that could be helpful? Did we do some data manipulation? Well, what if we look back at our results, when we get a response, we get the 64 bytes from IP address. But if we don't get a response, it looks like we get destination host unreachable. So what if we just want to see the ones that are up? That's our goal here. Is we want to see which ones are responding to ping. So what if I pipe my output and grep 64 bytes? What did I do wrong? Doesn't see it as a string. Need to put quotations around this. So now we're not getting all of that output. All we're getting is our 64 bytes from 192.168.1.1. And if I waited long enough, I would get some more, like, we know this one's 77, there's a 76, so they're a bit higher up. Right now we're just hitting the router. Yours may be different. So what we really want is this IP address here. We don't need all of this 64 bytes from and whatnot. So what we can do is we can use that cut command. Let's pipe this into cut. Delimiter is going to be space, and what field do we want? So let's see. So this is field 1, field 2, field 3, field 4. So we want field 4. See what we get now. Almost there. We have just that extraneous colon on the end, which is fine. It's perfectly readable. But if we want to put the output of this script into another script or into another program, if we need, say, for instance, a list of live IP addresses that we can use, then this isn't going to be ideal. So we need some way to get rid of this. So you might have to do some Googling for this one. We didn't show it in the previous module, but I mentioned it. One way to do this would be to use the sed command, and the correct syntax for that is single quote s slash dot $sign slash slash single quote. So basically that's saying take the last character and turn it into nothing. That honestly would probably be something I would Google. My sed is not all that awesome. So let's try that. Now it looks perfect. So if we let that run, that would go through and hit all of our IP addresses, and it would find additional systems open. We could, of course, do that append, so we could do the double greater than signs to send this all to a file. So if we wanted to save all our live IP addresses to a file, so we could input it later into another script, we could do that as well. Again, just a little example of scripting with bash. It's certainly worth knowing, if only to make your life a little bit easier. Maybe not as functional as some of the higher level languages, but if you know how to type into a Linux terminal, you can probably do some basics with bash. You just have to get your syntax for your ifs and your fors and your whiles and your other loops. It might not be something you're familiar with. Even if you are familiar with another programming language, it is a bit different. I don't typically see that backwards if and then the :do. That's not something you typically see in a lot of your other languages. So it may always be a little bit new to you. It's really difficult to be completely fluent in all the programming languages, for sure. You'll certainly get mixed up.